let's get moving. So we are recording. That's good. I don't want to make that mistake again. What questions do we have?
Is it possible to do on the gosh, what was it called? Your sample questions that you listed for like the previous test?
Yep.
I was just studying and working those at number. So I'm having trouble getting or figuring out the mean for number 11. My answer came out different, and then number 12.
Okay, let's take it.
I'm sorry, I meant 11 and 13. Sorry.
No problem. Let me share my screen. All right. All right. 11 and 13. All right. So looking for a mean of this guy right here. So it should
So I
just,
got the, oh, sorry.
oh, go ahead. Should,
I got the 190. I just the 216. I keep coming out with a different answer.
so my mean should be one lottery ticket you can purchase store has this payoffs. So their information. Okay. So 0 times 0.5 plus 200 times 0.2 plus 500 times 0.3. So that's our 190.
Yeah.
Now to get the standard deviation, I'm going to do this by hand first. I'm going to take 0 squared, which is 0 times 0.5, plus 200 squared times 0.2, plus 500 squared times 0.3. So that's like doing the mean, but squaring the x's first. And then minus from that 190 squared. This should give me my variance. And I get this number. Now to get my standard deviation from variance, I'm going to take the square root of that number. Second square root, this number, and there's my 216.56.
Okay.
Now that was doing it all by hand. I'll show you how to do it using your calculator. So I have my calculator. Here it is. Here's my calculator. I am going to go to my lists, edit. And I'm going to put the payoffs in list 1. So my lists look like that. I'm going to clear them out by going up to the L1, like so that the L1 is highlighted. And I
So
hit
to get there, do I have to do math first and then do, or I'm sorry, stats first?
yeah, hit stat and then edit.
Stat and then edit. Okay.
Now I'm going to go over to L2 and hit clear. And that's what my L1, L2 now look, they're cleared off.
Okay, perfect.
Right. And now I'm going to go like this. and enter in my payoffs. 0, enter, 200, enter. And 500. That's in list 1. And list 2, I'm going to put 0.5, enter, 0.2, enter, and 0.3. There's that. And now I'm going to hit stats, go over to calculate, and choose number 1 variable statistics. And in list, I'm going to have my list 1, and frequency, I'm going to have list 2. Second 2 gives me list 2. So it should now look like that. And then I hit enter. And you will see the numbers that you need are right there. 290 and 216.56.
Okay.
Okay.
That's weird. Mine's getting 205.
You entered your numbers in wrong. Are you getting 190 for your mean?
Yeah, I must have put numbers in wrong. Let me do it all over again here.
Stat, edit. And make sure this looks like.
Yeah,
Like-
0, 200, 500. Yep, I have that. 0.5, 0.2, 0.3. Yep, I have that.
All right,
And then
now you went to stat. 1 list statistics, you did L1 and L2.
L1 and L2.
You didn't choose L1 and L1 or.
Yeah, list L1 and then frequency list, I'm putting 2.
L2, not 2. Put in L2.
Oh, there we go. That's the problem.
Okay.
How do I get the L on there? Because I don't see an L on here.
If you hit the second button and then the number 2. So the second button up here and then the number 2 button down here.
Now I'm getting a 0.5 must be an integer.
Go back to your list, stats, edit. Go to where it says 0.5 and make sure it looks just like that. Maybe clear out the L2 list and try entering it again.
Okay. And I'm doing the 1 var stats, right? Not 2.
Yep, doing 1 var stats.
Cool. So I got 1 var stats, list L1, frequency list, list L2.
Good.
That's weird. I'll have to just mess with it. We can go on. I'll keep trying to
Okay.
mess with it. I don't know why I keep getting 0.5 must be an integer. That's weird.
You must have a comma instead of a point there.
Okay.
Check
I'll keep
that.
messing with that if you want to do the 13.
Okay. All right, so 13. There are 2 games involving flipping a coin. In the first game, you win a prize if you throw between a 40% and 60%. You throw between 40% and 60% heads. In the second game, you win if you throw 75% or more. For each game, you would rather flip a coin 50 or 500 times. Doesn't matter. All right, so let's take a look at what this would look like. All right. So in game 1, let me draw out a little thing. All right. All right. Game 1. All right. So let's say I flip it 50 times. So 40% of 50 is 20. So I have to flip between 20 and 60% heads. I have to flip 20 out of 50, which is 40%, or 30 out of 50, which is 60%. So if I flip any number in between here, I win. Otherwise, I lose, right? So I'm going to do a binomial CDF here because this is either win or lose. If I want to know what's the probability of doing this between 40 and 60%, right? I'm just going to go through the whole kind of grind it out process. So I'm going to go to my distributions on my calculator, second distributions, and I'm going to go down to binomial CDF. Right there. I'm going to hit enter. And the number of trials we have is 50. The probability of getting success is half. And my X value is going to be 19 because this is a left tail. I'm going to paste that. And I have this percent chance of getting from 0 to 19. From getting 0 to 19, my calculator gave me 0.0595. That's my chance, right, of losing down there. Now I want to do 20 to 30 wins. So between, if you throw between, probably should have done 20. It says between 40 and 40%. Is 40% between 40%? No, it's not. I'm going to do the same thing this time, except for I'm going to use 20 because it says between 40%. So, I'm going to do binomial CDF. Trials 50.5, X value 20, paste. Right. So actually it changes my probability of losing this bottom from 0 to 20. That probability is 0.101. It's the probability of getting, so 21 to 29 would win. And then 30 to 50 would lose. This is if I roll 50 times. If I roll 500 times, 20% of 500 is 100. So 0 to 99, well, to 100, because we decided up here that getting 20% is not between 20%. So 0 to 100, I'd lose 101 to 60% of 500 is to 299. I'd win. And from 300 to 500, I'd lose. Let's see if these probabilities match up. So now I'm gonna go binomial CDF again. My number of trials is 500. My X value now is 100. Which is, oh, but we want to do 40%, not 20%. Ooh, struggle bus tonight. 40% of 500. Is indeed 200. So this should be 200 to 201. This is 40%. This is basically between 40, 41-ish to up to 60. And this is 60% and above. All right. So if I go 500, X value 200, and paste. Yeah, it's a significantly smaller number. So that's much, much smaller. This was like 10% and this 0.00%. On this one, if I go from 29 down to 50, figure out what the probability of winning is. Again, I'm going to go binomial PDF. Now I'm going to go 50 trials, probability of flipping coin is 50%. I want anything 29 or less. I'm going to subtract from that answer, which is 90%. I'm going to subtract this 10%. So my probability of winning is 79% up here. And do the same thing right here. I'm going to go binomial PDF, CDF, trials 500, this time 299, anything less than 299. And then I'm going to take that out, the that little tiny almost zero out. My probability of winning down here is 99%. What? This is way better to play this game for the first game. And it's going to be way better to play this one for the second game. So your answer is going to be E here. Easiest way to see this is if I were to show you a little graph, what these curves look like. Let me drag a new window here. This is going to draw us a little graph. Here's 50. Right. See how this curve is kind of all mounded right in here. And this 21 to 29. And to get 75% or above, you actually have to get over here. It's kind of small. Okay.
Yeah.
If I change that to 500, This graph is not really letting me show it. Let's do. It doesn't like that number. It's too big for this applet. Let's try this one. Let's try this one. There we go. See how almost all the successes are between 220 and 280?
Yep.
So, but if I change it down to this guy, the successes are much more, like you have a better chance of getting these successes. So when you make this bigger, because the sample size is larger, you're getting closer and closer to the expected value. You get more rounded. When the sample size is smaller, you're going to have a better chance of getting some of these extreme values. You're the one where you're looking for 75% or more is better on this graph than it is on this graph. So
Okay.
this cut off. So for the first one, I wanted 60%, 40 to 60%. So basically I want between 200 and 300. And you get like 99%. If I change that for 50, between 20 and 29, this is only 54%. So
the odds are better of winning with the other one, the higher.
for the first one, the odds are better winning if you roll more. For the second game, the odds are better winning if you roll less. All right, let's take a look at some of these other questions. What are the questions you have?
I have a few questions on the homework.
Back. All right, which ones would you like to look at?
I'm kind of confused, like when I ask for a percentile or like one
Which
of the
homework
examples
is this homework number 8?
yeah, that's
Okay,
homework
just
8.
double checking.
Like for question 18, what is the annual rainfall for about 70 rainfall for the 75th percentile?
Yep.
It's like I haven't really.
All right, so first of all, we need to understand that this guy is a normal distribution. And do you remember what a normal distribution looks like?
I do not.
It's a bell. It looks like this.
Oh, right. Okay.
Okay.
Yeah.
Now, none of my normal distributions are going to look too pretty because, well, I'm drawing with the mouse. And, life is not always pretty with the mouse. All right, find what probability is the annual rainfall. Oh, it tells me in my problem that my mean is 41.7. And my standard deviation is 5.2 inches. Now it says, what's the probability of the annual rainfall of less than 44 inches? Well, 44 inches is right here, right? Because this guy down here is like a number line. So 0 is way down here. 41 down this way. Negative infinity keeps going down this way. Infinity is way over here. This is a huge giant number line, and we put this little normal curve right on top of it. And we want to know what's the probability of getting this or less. So we're looking for this area right in here. All of this area. 44 or less. Just by looking at this, I know it's going to be more than 50% because I have more than half of this curve shaded. My standard deviation is 5.2, and this is less than going up one standard deviation. So if I went up one standard deviation this way and had 50% shaded over here, I'd be at 84% roughly by the empirical rule. This is going to be less than 84%, but let's find out exactly how much it is. Okay. So what I'm going to do is I'm going to use my calculator to calculate the area underneath this curve. Okay. I'm going to use my calculator to calculate the area underneath this curve. That's less than 44. So I'm going to go on my calculator to distribution. I'm going to go to normal CDF. It says, hey, what's the smallest number you want? I want negative infinity, but my calculator doesn't read negative infinity. So I put a really big negative number in there. I put a -1 with lots and lots of zeros. In fact, it's got 99 zeros there. If your calculator doesn't say -1e to the 99, you can just put a -1 and then hit 0 key 15 times. It'll be fine. Hit 0 key 10 times. That'll be fine. Just hit a bunch of zeros. Right? You want a really big negative number. Okay. And then it says, what's your upper limit? I want to go up to 44. And it says, hey, what's your mean? In this case, my mean is 41.7. What's your standard deviation? It's 5.2. So I enter in all the points of my problem. Now this is giving me a probability. It has to be a number between 0 and 1. Okay. 0 area would be infinitesimally small. And 1 area is if the whole curve was shaded. I don't have the whole curve shaded. So I hit paste and enter, and it's 0.67. So to 4 decimal places, it's 0.6709. So I go in here to 4 decimal places. 0.6709. And that's right there. Okay. Now, what's the probability it's more than 38? So how does that change my picture? The more pictures you draw, the better you're going to understand this. So I draw my curve. 41.7 is in the middle. Your curves don't have to be pretty. Your sigma is 5.2. I want more than 38 inches. So 38's over here. It's underneath 41. And I want more than that. So I want this. Now keep in mind that this is more than 50%. So once again, this area should be somewhere greater than 50. This is not a full 5 below the mean. So it's going to be less than 84. Because there's 34% between the mean and 1 standard deviation away. So I'm going to take my calculator again. Go to, you're like, I don't have a calculator. And I'm not going to buy one this term. You can use Minitab. So I'll go to Minitab real quick. Show you how to do it on that. So I go to Minitab. If I'm going to my calculator, I hit distribution, my lower limit's 38. My upper limit is like one with a whole bunch of numbers. So like 1,000,000, 100,000, just 1,000,000. And then I put in the same mean and the same standard deviation. On Minitab only gives me my left curve, my left tail, the left side. So I go here, cumulative density, normal. My value is 38. My mean is 41.7. My standard deviation is 5.2. I hit enter. This gives me this left number, 23.8375. That's the wrong side. It's giving me this side over here. I have to go 1 minus that, 0.238375. And I get this number, 0.7616. I want to check that, make sure I did that right on my calculator. I'd go distribution, normal CDF, lower limit 38, upper limit 1 with a whole bunch of zeros. Looks like this. I'm going 38 to a really, really big number. Hitting paste. And I'm getting the exact same number there. Going back to that problem. Okay, so this one was 0.76162, so 16. Okay. What's the probability it's between 37 and 42? Let's draw a new picture. So I've got my guy there. My mean's at 41. So 41.7. So I want to find the area between 37 and 42. Now, if I do it on my calculator, it's really easy. I'm just looking for this area in between here. So I'm going to go on it. Oh, Siri thinks she's on it. I don't know why she got involved. I'm going to go. All right. Want to hear my funny Siri joke? I know you do. So I'll tell you. So a guy says to Siri, "Hey Siri, why do I have such terrible luck with women?" And Siri answers, "My name is Alexa, stupid." On it. Okay. All right, now we're going to go over here to distribution, normal CDF. Now I want it to my lower limit to be 37, my upper limit to be 42. Mean stays at 41.7, standard deviation at 5.2, hit enter. And I have 33% of the data right in there. So this is 33.99. 0.33996. So 996 rounds the 9 up, rounds that 9 up. So this is 3,400. Right. It says what annual rainfall would fall in the 75th percentile. And I just realized that was your question. So you probably knew how to do all this. And I just blubbered all of this on. So sorry about that.
Well,
But
it's okay because I just put these into my calculator and didn't really understand the concept behind it. So at least now I understand.
good. Well, that's comforting. Good, good. So from here, we're going to try to find that 75th percentile. I'm going to draw another picture because that's the easiest way to see these things. So Here I have my curve. I want this at 41.7. My standard deviation is 5.2. Right. I'm looking for a number up here where 75% of the data, where this area down here is equal to 75%. Right. So instead of using normal CDF, which I put in limits, you put in limits and you get out area, limits, give area. I'm going to use a function on my calculator called inverse normal, where I put in an area and it gives out a limit or a cutoff. Okay. So on my calculator, I'm going to go distribution. And there's one on here called inverse norm, which is number 3. Now on some calculators, it only gives you the left. The new RTIs give you an option between whether you want the left, the center, or the right. In this case, I want the left anyway, because my left part is shaded on my graph.
So if I want the right, do I just do like 1 minus my answer and then?
Yeah. If you wanted the right and yours doesn't have left, right, center, then you just do
Yeah.
1 minus your answer on the left.
Okay, sweet.
So my area, I want to be 0.75. My mean is 41.7 and my standard deviation is 5.2. And I paste. And my cutoff that I need is 45.2 inches of rain is in the 75th percentile. So I'm going to put here. $45.2073. That gives me everything I need. Right.
When you were entering the area, did you do 0.75 or just 75?
I did 0.75.
0.75. My mean is 42.1. Standard deviation is 5.2. Actually, I think I already know the issue because I didn't do 4 decimal points.
There you go.
Like another one I'm confused on is question 15. I feel like it's very basic, but I just don't understand it.
Question 15. Okay.
16 really, both of them.
Okay. Yeah, these are both uniform distributions. All right. So let me clear these. All right. So the difference between a normal curve and a uniform distribution, right? A normal curve is like this. It's like height. There's some super shorter people, and then gradually, then the bulk of the people are about average, and then you have some like obscenely tall people, right? So if you had a group of 100 people, right, you would expect 68 of those 100 people to be pretty close to the mean. And then as you got taller and taller, it would get less and less. Or as you got shorter and shorter, you'd get less and less. So height is like a bell shape, right? It'd be very different if height were uniform. If you had 100 people, and let's just say like the average height is for, let's just say guys is, 5'10" or 5'8". I don't know what the average height is, 5'8" or whatever. And then you had like most people were between like, 5'6" and 5'9", 5'10". And then as you got up, over 6 feet and 6'2", it just, got less and less people. And under, 5 feet and 5'4" and so on, you got less and less people. That would be different if your average height was 5'8" here. And then you had the same number of people who were between 5'6" and 5'8" as were between 6 feet and 6'2". Like that's a very different type of distribution, right? This is evenly spread out, and this has a big clump in the middle around the average. This one does not have a clump around the average, has the same average, but it's evenly spread out all the way. Okay. So one important thing, though, they're both probability distributions. So the area under their curve is still equal to 1, regardless of the shape. The area under the curve is still equal to 1, regardless of the shape, because they're probability distributions. So 100% of all the possibilities have to be under that curve. All right, so this one for 15 says it's uniform. What's from this density, the probability is at least 0.7 is, so here's 0.7. And I'm looking for this area of 0.7. Now this whole rectangle has to have an area of 1. And the area of a rectangle is length times height, or let's say length times width. It's more common, right? So our length is 2. And when I times 2 by something, I have to get 1. So this width must be 1/2. So in order for the area of this whole thing, the area of this whole thing to be 1, this height has to be 1/2. And it turns out that height is always going to be the reciprocal of whatever your length is. That's how you get 1. All right. Now, I want to find out what's the probability that this is less than 0.7. So I want the area of this little brown rectangle right here. So the area of a rectangle is length times width. My length is 0.7. My width is 1/2 or 0.5. 0.7 and 0.5 is 0.35. So this should be 0.35. How's that feel for you?
So for mine's just 0.6. I did I did 0.6 times 0.5. It's 0.3, but I need more decimals. 1 second.
I'll put 0.3000.
Yeah. Oh, yeah, I was still wrong. What did I do? Mine says it's 0.7.
Yours says is 0.7?
Yeah, so my everything about my question's the same as yours, but instead of your at least 0.7, mine's at least 0.6.
And it goes
Maybe
from 0, it goes from 0 to 2?
Yeah. So I
Oh,
guess I
I'm
just want
sorry.
to know the other side.
This is totally my fault because I read that as less than 0.7 and it's at least 0.7, which means it's 0.7 or greater. So I took the wrong rectangle. Right? At least is bigger, and I just,
Oh, right. No.
so we actually want this rectangle right here.
And
And the
then
length of
how
this
do you,
rectangle is 1.3. Right? From
yeah,
here to here, times a half. So 1.3 times 0.5 should be 0.65. Which is also the what if I take 1 minus that, I get 0.65. So your answer should be 0.7000.
and then how do you know when you did 2 times width, how did you know it equaled 1?
Because it's a probability distribution and
Okay, so
100% of the possibilities has to equal 1. So
okay, so
whenever you have a probability curve, the area has to equal 1 because that's
okay,
100% of the probabilities.
okay.
Yeah.
Cool. Can we do question 16 as well?
Yes. All right, so I'm gonna clear my pictures here. All right, so on 16, it says the lengths of class are 50 minutes to 52 minutes. It's pretty consistent. That means this distance right here from 50 to 52, this length is 2 again, which means that this width is 1/2. Because again, this probability has to be 1. Now it says, what's the probability that the length of class is between 51.1 and 51.9? So we want this little sliver right here. It's not that little, 51.1. No, 51 is going to be in the middle. Let's try to make it look right. 51.1. So 51.1 is there and 51.9 is over here. We're looking for this area right here. So 51.9 minus 51.1 is 0.8. That's length here. And 0.8 times 1/2 is 0.4. And it's between those two. So that should be the right answer, 0.4.
They're talking about minutes, not length. So because if they're talking about minutes, is that the same way to do it?
So they're talking about the probability that, so this right here is in minutes. 50 minutes to 52 minutes. That's the unit, right? So our units on this line right here are minutes. 50 to 52. Right. Right. So the area of this rectangle, the area of this rectangle has to be 1 because this has to have 100% of all the different possible lengths in minutes that a professor can talk. So his class could be 50 minutes long or 50.3 minutes long or 50.4 minutes long. It has to contain all the possibilities from 0 to 52. That makes sense so far? Good. So now he says, here's 51 is going to be right in the middle, right? Now it says, what's the probability that this professor talks from 51.1 to 51.9, right before 52 minutes? What's that probability? In order to figure out this probability, I figure out the area of this rectangle in between. So I am looking for the area of this little rectangle right here. That's going to tell me what portion of the big rectangle. So basically what I'm asking is, what portion of the big rectangle is this yellow rectangle? And that tells me my probability.
For the upcoming test, is there any questions? We don't have to go over them because it's 8:30, but that a lot of people usually get wrong that I should study extra on, or and is it pretty similar to the practice exam you sent us?
I haven't looked at it in a while, so let me take a quick look.
So my question 16 has different numbers.
Right?
And so that would be the formula, guys, that would be the formula I use and just put my length between 50.2 and 50.3 instead of the numbers that you used.
So do you have 50 and 52 here?
Yeah, but so instead of they want to know on your question was between 51.9 and 51.1,
Uh-huh.
it's between 50.2 and 50.3.
Okay, so
So
what's the difference between 50.2 and 50.3?
Sorry, I froze for a second there. The difference between it's 0.1.
Good. So now take 0.1 and times that by 1/2.
0.1.
Times that by 1/2.
Okay. Sorry, I literally have been going through like everything since I lost my notes. uh so it's 0.05.
Yep, 0.05, and that should be your answer.
Okay.
If you put
Awesome.
0.05 in there, make sure that works.
Okay. Sorry about that.
That's okay. No, it's a good question. No need to apologize.
Oh, it worked too. Yeah, the last one was also like every time we do these, mine are just a couple numbers off from whoever's doing their what do you call it? So I try to really quick write down how you do it so I could go back and do it with my numbers.
Yeah, everyone's gonna have different numbers. That's so that everybody
Yeah.
gets a chance to practice on their own. It'd be really boring if we all had the same numbers.
I know, right?
All right, so questions on this exam. Let's take a quick look.
So the work that we did this week, week 8, is going to be on also?
I don't
Or
think
no?
so.
Okay.
In fact, I know not.
Okay.
Goes up to week 7.
Up to okay. Oh, praise
Yep.
God. Okay. That is awesome.
Let's see. Tomorrow is Thursday already. Crazy. It should open tomorrow at 10. Okay, let's take a quick run through what we got here. Lots of questions about probability distributions from last week. That's like finding the mean and the standard deviation, like the ones we started with, the expected values. You know, what would the payoff be? Binomial distributions will be on there. Basic probability questions. So basically stuff up to week 7. Those problems that have tables and they ask like, given that, like those types of questions. You know, if you have a table, you know, people who sit in the front row and people who sit in the back row and boys and girls, given that they're a girl, what's the probability they sat in the front row? What's the probability, you know, that type of thing. Yeah, I would take a good look at your homework questions between week 4, 5, 6, and 7, those 4 weeks. 4, 5, 6, and 7.
Awesome. And then the same thing for Proctor, right? I think, right? I sent you the email for the live Proctor, and then I sent you an email for the for lab 1 we talked about last week. I think I sent
Oh
the
yeah,
email the
you
other day.
resubmitted lab 1. I haven't had a chance to look at it yet.
No, you're good. And then I just emailed you for the Proctor as well.
Okay. What did your email for the proctor say?
Oh, just saying who it's going to be
Oh, great. Awesome.
in their email.
Perfect. Great. Yeah, after we hang up here, I will get that testing information out to Proctor so they have it by tomorrow morning.
Sweet. Thank you. I won't do it tomorrow, so you're okay. You don't have to. You don't have to do it tonight.
No rush, no rush. But somebody might do it tomorrow. Somebody might be on it. It's
Right.
highly unlikely. I think the probability is less than 1%.
Oh, for sure.
When my proctor told me he can't do Saturday, I was like, no. Just, and he said, oh, really? Is one day going to make a difference if you do it Friday? So no, you don't even know.
Are you doing it on Friday then?
Yeah, I have to do it Friday because he's
Me
not
too.
available at the weekend.
Oh, bummer.
Yeah, I was a little bit sick in my heart. I was like, okay, at least I have my notes. And that's how I discovered I lost them. The notes are gone. Like all of the notes from I'm really embarrassed to say, like, I've been crying all day looking, trying to scribble down everything. Like,
Oh, no.
yeah, I'm like, okay, on top of everything that like the story at you, I have now lost these notes. Come on. So yeah, but it's the same proctor, so I will have him text you, or
Yep.
you probably emailed me back and I haven't seen it yet. I'm sorry.
Yeah, I emailed you back and just said, hey, send me his email again, just so I have it and make sure I have
Okay.
that one. But yeah,
Okay,
good.
thank you.
No problem. He seemed like a really nice guy when we communicated. So
Oh yeah, he's lovely. He's a really great guy.
good.
Thank you.
All right. Well, good luck, you guys. I'm sure you'll do awesome. Feel free to drop me an email if you have any last minute questions.
Sounds
Okay,
good.
thank you.
Take
Good luck,
care.
Colby.
Thank you. You as well. Hopefully it goes good. Find out.
Okay.